How are similar triangles used in engineering designs? Imagine building a model of a skyscraper or designing a bridge. How do engineers make sure everything will fit and stay strong? The secret often lies in the idea of similar triangles. Similar triangles are shapes that look the same but are different sizes. They have the same angles and their sides are in proportion. This means if one side is twice as long as in the other triangle, all the sides are doubled. Engineers use this property to work with shapes that are scaled up or down, keeping the same proportions. One common use is creating scale models of buildings or machines. For example, if an engineer makes a small model of a bridge to test its strength, they use similar triangles to make sure the model accurately represents the real bridge. This way, they can test and make adjustments without building the full-size structure first. In structural engineering, similar triangles help in designing trusses and supports. These are the triangular frameworks in bridges and roofs. By using similar triangles, engineers can calculate how forces are distributed in the structure. They can figure out how much weight each part can hold, even if the actual structure is very large. This helps prevent collapses and ensures safety. Surveyors also relying on similar triangles when mapping land or measuring heights. They measure angles from to points and use the proportionality of similar triangles to find distances that are hard to measure directly. For example, to find the height of a tall building, they measure the shadow it casts and the shadow of a nearby object. Using the ratios of the triangles formed, they can calculate the building's height without climbing it. In optics and mechanical systems, similar triangles help in designing lenses and mirrors. They ensure that light is focused correctly or forces are transferred efficiently. For example, in a camera, the shape of the lens uses similar triangles to focus light precisely onto the film or sensor. Overall, similar triangles make complex engineering problems easier. They help in scaling designs, measuring inaccessible distances, and analyzing forces. This geometric idea simplifies many tasks, making sure structures are safe, accurate, and efficient.